Hello everyone, welcome back to Decode with Sahil. So today we are going to solve our next problem. Find minimum in rotated sorted array. So let's read through the problem. So suppose an array of length n in ascending order is rotated between 1 and n times. Okay. For example, the array 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it is rotated 4 times. Okay. So now if we rotate an array one time, so suppose if we rotate this array one time, so what this array would become? So it would become like 7 would come in the front, right? Then 0, 1, 2, like this. Got it? So, and if we rotate this array two times, so it would be 6, 7, 0, 1, 2, 4, 5, 6. You got it? So if this array is rotated four times, then this will be this array. Okay, this, right? Now, it is asked that given the sorted rotated array nums of unique elements, the elements of this array are unique, we need to return the minimum element of this array, minimum element. So we need to return the smallest element of the array. It's simple, right? It's simple. But it's also mentioned that you must write an algorithm that runs in log n time. So first of all, let's go through the problem. How we could solve that, how we could approach that problem. So if I think of a naive approach, like, and also obviously look through all the constraints first, okay, before moving on to the problem. So now if we consider this example, okay, so now we need to find the minimum element. So what is the naive approach we can look for? We can look for, like, we can iterate through the array, we can take a minimum element. Okay, now I'll iterate over the array. Okay. Now, whenever I encounter a new element, I'll compare it with the minimum element. If it is smaller than the minimum element, I would replace the minimum element, right? So this way, after whole iteration of the array is done, I would have the minimum element as the answer in my variable, right? And that would return the answer. But that would return in n time complexity because we are iterating through the whole array to get the answer, right? But if we need to finish it in log n time, which is a better time complexity than n, so we need to tweak the approach. So now, whenever we are given that we need to find something in log n time, and we are given an array, think of binary search. Binary search is able to search in log n time, but binary search always works in sorted array, right? But this array is also sorted, right? But what is happening is that the sorted array, it's rotated. It's rotated some amount of times. Okay. So now what we can do is that we can follow the binary search approach. Okay. And we can tweak it a little, right? Like, suppose if we take this example, okay. So what we do in binary search, we take a left element, we take a right element, and we take a mid element. And we kind of compare it with the elements to the right and to the left. So in the modified binary search approach, what we can do is we can compare this middle element. If it is greater than the rightmost element, that means the smallest element is at the right half of the array. Makes sense? Because because think of it, the smallest element would either be at the 0th index, or if it is a rotated, so it is next to the largest element of the array. Makes sense? So what we can do is, so if it is greater than this, then it is at the right half. If it is smaller than this, then it is at the left half. So this way, we are reducing the search space and we'll get our answer. So I'll write the code so that you would understand it better, and then I'll run it for you. So I would take uh, a variable left for 0 index. I would take variable right for the rightmost index. So it would be nums.length minus 1, right? Now I would run the loop until left and right pointers meet. Okay, if they will meet each other, means we are at the smallest element. Okay, now I would find the mid. So what would be mid? It would be left plus right by 2, right? Now, here there's a problem. So what the problem is that this line could cause overflow. how it could cause the overflow. Suppose if you have an array of larger size. Okay, if you have an array of larger size, so this left plus right might go beyond the integer range. So the integer range, it might cross the integer range and we might get the stack overflow error. So we need to avoid that error. So we are calculating mid only, but there is a different way to calculate. Okay, so we can do left plus right minus left by 2. So this would also necessarily calculate the mid only, and it's the same formula, but it will avoid that overflow error. So make sure you follow this particular approach to calculate mid every time you do a binary search problem. Okay. Now we need to see like if the middle element, if it is smaller than the rightmost element. Okay. So if nums of mid is smaller than nums of right. If it is smaller, then what we have to do? If it is smaller, then we have to search in the rightmost part of the array because the smallest element would be at the rightmost half. Okay. So then I would increment the left to mid plus 1. Similarly, if the mid is greater than the leftmost element, then the smallest element will be at the leftmost half. You got it. So I would change right to mid. You might be thinking why I did not do mid minus 1 because middle element could also be the smallest element, right? So we can't ignore that element, okay? So now left and right would eventually meet at some point. So I could have the answer in any nums of left or nums of right, okay? So what I'll do is I'll just go here. I would return nums of left. That would be my answer. Okay. I'll quickly run this code. So I think there's a mistake with the code. Let's see. So I have calculated the mid. Okay, that is correct. Oh, okay. So here nums of mid should be greater than nums of right. Right? I accidentally put the less than condition, but it should be greater. Okay. So now I think it should work. Okay, all right. It's accepted. I'll just quickly run the code. All right. So it's working as expected. So now what I have done here is let's try run this example. Okay. So left is 0, right is 4. Okay. Now left is less than right. So we calculated the middle. So that comes as 2. Okay. Now, if nums of mid is greater than nums of right, so is 5 greater than 2? Yes. So left becomes mid plus 1. So left becomes mid plus 1 means left is at this index now, right is at this index. Got it? Now, again we uh, go in the loop since left is less than right. Okay. We calculated the mid, which came as this. Okay. Now, is nums of mid greater than nums of right? No, it's small. So it goes to the else condition and right comes to mid. So now right will come to this. Okay, so now left and right both are pointing to number 1. Okay, now again it goes to the while loop, but left and right are equal, so it goes out of the loop. And we are returning nums of left, which is our answer, which is the smallest element, right? So you see, like it's pretty simple to do it with binary search. If you want to do it in log n time complexity, so binary search is the way to go, right? So I hope you got the idea of it, and let me know in the comments if you want me to include some more things or more visualizations. I'll see you in the next video.